Hello, everyone. I'm Shahab Darakshan, one of the instructors of Chem 111A class. So in this set of video clips, which are going to be short ones, I'm going to focus on some foundations that are going to be very helpful for your success in your upcoming Chem 111A class. So we will have some like 15 minutes type videos. So I want you to watch them before going to your M95 sections. By having this type of preliminary knowledge, you will be able to solve those problems. So today I'm going to talk about measurements, and that's one of the very important aspects of any physical sciences. So whenever you go to any lab, you are measuring something, but you want to know what is exactly we mean with measurement. Basically, when I'm talking about measurement, I'm comparing some quantity with some standard, with some known and agreed upon standard. So for example, you guys are familiar with the concept of mass. So mass is a concept which is related to some sort of measurement. It's amount of the material, but it's compared to some unit number. So for example, the unit that we use for mass is kilograms, or for length, we are comparing the length of object to something which has the length of 1 meter in standards. Obviously, we have different types of units for any of them, but the idea here is just some sort of comparison. So here I'm going to introduce the standard units, which are basically some agreed upon standards for different quantities. For instance, when we are talking about length, as I mentioned, we show it with the unit for length is meter, as shown here. And so let me see, how can I change my settings so I don't draw? So basically, I'm talking about meter here, which is the unit for length, and it's shown by lowercase m. Or for mass, we are talking about kilogram, and we show it with kg. And for time, we say the unit is second, and we show it with lowercase s. And for temperature, the scientific unit which we agree upon is Kelvin, and it's shown with upper capital K. Now, these four are our fundamental quantities, obviously, but we also have some derived units out of these guys. Let me move to the whiteboard. So for example, we learned about unit meter, which is related to length. Alternatively, we also know about second, which is related to time. In general, you can measure length. You can also measure time. But we are also talking about some derived concepts such as velocity. When I'm talking about velocity, I'm simply talking about the length which is traveled over certain time. So you can see that the quantity of velocity is related to two fundamental quantities, namely length and time. And obviously, when we are looking for the units for velocity, we are talking about meters per second. And when I say meters per second, this is my SI units. And we have different types of units, such as kilometers, we have hours, we have other miles, And you can also do unit conversions that we are going to discuss them later. But generally speaking, when I'm talking about measurement, I'm always comparing a given quantity to some known unit. So a length of object, which is 1 meter, or 1/86,400 of 24 day and night. So we have 86,400 seconds per day. So that's how we define some parameters and we agree upon them. Okay. So let's move forward. We talked about different fundamental units. So here we are talking, for example, about length. So clearly we have different ways to measure length based on different standards. In scientific community, we are talking about meter sticks, but in environment and different communities, they have different standards. So for example, yardstick is some other way of measuring length, which is happening in different communities. And there are always a relationship between, for example, yard and meter. So in SI unit, we are talking about meter, but you can also use centimeter, which is related to meter. Or we know that 1 meter is equivalent to 100 centimeter. So right here, I'm going to give you a heads up that later on, we are going to talk about unit conversions, for example, how we can go from meters to centimeter, knowing these facts. So for understanding that 1 meter is equivalent to 100 centimeter is a tool you have. And later on, I'm going to show you how you can use these tools to solve your problems. So alternatively, you can say 1 meter is equivalent to 100 of meter, or it's 10 millimeter. Again, that goes to the concept of unit conversions. But these are some facts that we know, and we are going to use these facts as tools to solve our problems. Or 1 inch is equivalent to 2.54 centimeters. So you don't need to memorize these unit conversions, but whenever it comes to centimeter or millimeter, those are prefixes, you need to know them, but yardstick or inch, those are not necessary conversions that you need to memorize. They will be provided to you for solving your problems. Again, we talk about mass, and mass relates to amount of substance. Amount of substance can be measured, and that measurement can be done by comparing the mass to an object which weighs 1 kilogram. And those are going to be helpful later on to measuring things. Similar to the fact that we talked meters could be related to centimeter or millimeter, obviously kilogram can be related to grams or pounds or tons. So those are again in the concept of unit conversion. We have multiple ways to measure the mass. Amount of matter present in an object. So SI unit, as we discussed, is kilogram. And depending on what we are weighing, we can use different subunits. So for example, in lab, we are usually measuring things by grams and milligrams. And as I said, we have other units such as pounds, for which you don't need to memorize these things. There are unit conversion between kilogram and pound and gram. Those are things that you don't need to memorize, but you need to know prefixes that are used. When I'm talking about kilo, I'm talking about 1,000 of something. So when I say kilogram, I'm talking about 1,000 gram. Milli is 1/1000. So when I'm talking about milligram, I'm talking about 10 to the power of -3 grams, basically. So these are the prefixes I mentioned. These are things that you need to know. They are based on factors of 10. 10 to the power of 6 is mega, 10 to the power of 3 is kilo, and so on and so forth. If you have something above your unit, you are using kilo or mega. Something is below what you are talking about, you can go with deci, which is 1/10 of something, or centi, which is 1/100th of something. Micro, nano, and pico in some special cases are used. So if you remember, we talked about fundamental quantities. We also talked about derived quantities. So for example, we talked about velocity. Velocity was distance traveled over the time. So we used distance, which is with length, and we also used time, which is related to second, for example. Now we are going to introduce another concept, namely density. Density is the mass of an object in a given volume. So when I'm talking about mass of object, I'm definitely talking about mass. And when I'm saying per, right away you put, and then you say over volume, you say mass over volume. So it's going to be this. And then you say density is mass over volume, mass divided by volume. So it's a fraction, basically. So for mass, we know the unit is kilogram or gram, depending on what unit you want to report. But in scientific community, we talk about kilogram. And when we are talking about volume, we are talking about cubic meter. So I want you to note here that even volume is not a fundamental unit. So when I'm talking about volume, I want you to think about an object which is cubic. So obviously you can measure length. This is, for example, in meter. The length is also in meter. Also, you can say that height is in meter. So you know when you are measuring volume, this is length, which is in meter. This is width, which is in meter. This is height, which is in meter. So when you are measuring volume, you say it's length times width times height. So if this unit is meter, and this unit is meter, and this unit is meter, for volume, you would have cubic meter, meter cube. So this is cubic meter, which I'm using here. And now that I'm talking about density, I'm talking about kilogram per cubic meter. So that's how you can derive the units for different quantities. So later on, for example, we are going to talk about moles. Moles is a measurement system. We'll talk about those things, but I just want to give you foundations on general ways of measurement, units, and how we can relate those units to each other. So we said density is the ratio of mass over volume.